A laser rangefinder is locked on a comet approaching Earth. The distance g of x in kilometers of the comet after x days, for x in the interval from 0 to 24 days, is given by g of x equals 200,000 times cosecant of pi divided by 24 times x. A. Evaluate g of 5 and interpret the meaning. B. Graph the function over the interval from 0 to 24, including the endpoints. What is the minimum distance between the comet and Earth? C. When is the comet's distance from Earth the minimum? And D. What happens to the distance between the comet and Earth when x approaches 24 days? I've already set some of this up in Desmos. I've entered the function in cell 1. I've also adjusted the window. Notice the x-axis goes from 0 to 24. The y-axis goes from negative 100,000 to 800,000. Also notice that I am in radian mode, which we should recognize is required because of the pi in the input of the cosecant function. To determine g of 5, we simply go to cell 2 and enter g of 5. Recall 5 is the input in days, and the output is kilometers, which represents the distance between the comet and Earth. To the nearest kilometer, the output is 328,536 kilometers. This indicates the meaning of g of 5 is, after 5 days, the comet is approximately 328,536 kilometers from Earth. For part B, we're asked to graph the function and then determine the minimum distance between the comet and Earth. Part C is related. Part C is, when is the comet's distance from Earth a minimum? Going back to the graph, we need to locate the lowest point on the graph from 0 to 24, which is this point here. If we click on it, Desmos will give us the ordered pair, which is 12, 200,000. Recall 12 represents 12 days, and the 200,000 represents 200,000 kilometers, which is the minimum distance between the comet and Earth. And this occurs at 12 days. This is what we need for parts B and C. So again, the minimum distance between the comet and Earth is 200,000 kilometers, which is the function value or second value of the ordered pair, and the 12 is the value of x, or the time at which the minimum distance occurs, which means for part C, the minimum distance occurs at 12 days. For part D, what happens to the distance between the comet and Earth when x approaches 24? Going back to the graph, notice as we approach x equals 24, we are moving to the right along the function, and the function goes up indefinitely, or increases without bound, and the function value, which is the distance between Earth and the comet, approaches infinity. To answer the question, as the number of days approach 24, the distance between the comet and Earth increase without bound and approach infinity. I hope you found this helpful.